Okay. Good morning to all the students who are joined online. This is Professor David Koilpillai from IIT Madras. This is a quick review come interaction on the Multirate DSP course that we have been having over the last 12 weeks. Very happy to have this opportunity to interact with you and also to answer any questions as we come down to the last sessions of the course and also in preparation for the final examination. So we will begin this interaction with answering a few questions that have been sent to us, and also the lines are open, so you can type in some questions and we will answer them as we proceed. So the first aspect or the first question that was given to us was to get a clarification on the model of the question paper. The model of the question paper will be very similar to what you have seen in the weekly assignments. It will be completely based on multiple choice. There will be a total of 50 questions, 50, which will be for the duration of 3 hours. So hopefully there should not be any time pressure for you. The entire portions, what we have covered in the 12 weeks, will be covered in the questions with fairly equal weightage. So it is not biased towards the last few sessions. It will cover all of the weeks and the material that we have covered. Just one aspect that I thought I should highlight is that some of the questions have linked questions. That is, there would be one description for which there could be two questions. So in that case, very important that you spend time to answer the first question, because the second question could be building on the first question. So just take a little extra time whenever you have questions which are linked, so that you are able to get the full all the solution, all the answers correctly. So that is by way of a quick summary of the question paper and the pattern. If there are any other questions, we'll be happy to answer them. You can post them online. Regarding the assignments, we have had 12 assignments, and the answers for all the 12 will be available. The only thing that we normally do not post is the complete solution. So basically, the detailed workings. However, if a particular student has a difficulty, please post it on the course website, on the chat page, and we will make sure that the answers are explained, and also if any detailed explanations need to be given, they will be added as well. So as a general guideline, we do not post the complete solutions. We would much want to encourage the students to attempt the solution. If for some reason the answers that are given in the assignment are not clear, then we'll always be happy to provide some additional solutions. Okay, so that is by way of a quick input regarding the answers to all the questions. Answers provided, not the detailed working. We'll be happy to provide additional explanations as needed. So that's the second aspect. Are there any other questions that you would like me to answer before we begin a quick review of the material that we have covered? Please do feel free to post it. Let me spend a few minutes. Okay, there's a question which says, no, I think I would rather prefer that you tell us which assignment, which question that you are facing a difficulty, because in many cases, we may need to provide explanations for specific doubts that you are having. So we'll be happy to do that. Please post the assignment number and the question that you're facing difficulty, and we'll provide that. Okay, so what I thought would be helpful is if we could quickly review the material that we have covered. Maybe a good way to look at the key elements that we have covered in the last 12 weeks. So I begin with the last unit that we have covered, that is on A to D converters. A to D converters. Okay, so that was we approached this as an application of the uh, multi-rate aspects. So we looked at the traditional A to D converter, where you have a B plus 1 bit quantizer. Then we looked at the benefits of oversampling, and then after that, the benefits of noise shaping. So all the three elements are important for us. How does a conventional A to D work? What are the advantages when you have oversampling, and then what are the advantages when you have oversampling plus the noise shaping? So again, the type of things that we would like you to be familiar with are what is the quantization noise that you would experience if you had a certain number of bits, or what is the signal to quantization noise ratio, how many bits for to achieve a certain signal to noise ratio, and so on. Okay, there's a question which has come in, assignment number 9, question number 2. Yes, we'll be happy to, I don't have the assignment questions in front of me, but we will post a detailed answer to the assignment to question number 2 in our discussion, in the discussion forum. So the last unit was on the A to D converters. So let me, so this was the last, the previous to that, before that, the weeks that preceded that, weeks 10, 9, 10, and 11. That were the chapters that were relating to the multi-carrier transmissions. Multi-carrier transmissions. So one of the key things that we would like to like the students to be familiar with are the multi-rate representation. Multi-rate representation. This would be for the what we would see on the transmit side and on the receive side. And okay, so multi-rate representation at the transmitter side. Transmitter side. This is a what we would call as a multiplexing operation. Transmitter side is a multiplexing operation, and at the receive receiver side, it would be the demultiplexing operation. Let me show you a couple of figures which you will recognize from the lectures. So the conversion from serial to parallel conversion, that would be done by means of a chain of advanced operators followed by downsampling. This is also called the blocking operation. This is the serial to parallel conversion, and this is what is done at the this is done at the receiver. Now, the what we have at the transmit side is a parallel to serial converter, which consists of upsampling followed by a chain of delays. This is what. And if we now look at the multi-carrier transmit structure, you find that we have M signals that we want to transmit. They are going to be multiplexed in a frequency division multiplexed format. And that is the combined signal is X of N. This would be passed through a channel, C of Z. This could be a multi-tap channel, which represents the indecibel interference of the signals that are being transmitted. This is additive Gaussian noise, and then followed by the analysis stage, or where we recover the individual signals. So this is the overall transmultiplexer architecture. This also happens to be our framework for a multi-carrier transmission. So this is very important. Please make sure that you are comfortable with analyzing this multi-carrier transceiver. Now, very quickly, what are some of the elements that we need to have in this context? Next slide, we will just look at that. We can apply the polyphase decomposition both at the transmit side and at the receive side. just as an illustration of what we can do with the polyphase decomposition. So basically, we have done the type 1 polyphase decomposition at the transmit site. Let me highlight that. Type 1 polyphase decomposition at the transmit site. Decomposition at the transmit site. Type 2 polyphase decomposition on the receive side. Polyphase decomposition at the receiver. Now, there's a second element that I would like you to keep in mind, and that is the aspect of the redundancy. The redundancy is the fact that I want to transmit M channels, but the upsampling is being done by a factor of n, where n is greater than m. Okay, this is the aspect of redundancy. So to capture the effect of redundancy, the polyphase decomposition will result in a rectangular matrix. G of Z will be a rectangular matrix, and that is what we are showing here. Now, if we involve this for both at the transmitter and receiver, then what we will get overall is the polyphase decomposition at the transmit side, the channel, followed by the polyphase representation on the receive side. Okay. Now, with this as the overall framework, we are now able to derive two types of multi-carrier transmission schemes. The overall transfer function between the input and output can be obtained. It's a linear time invariant system, which depends on the channel, depends on the synthesis filters or the filters at the transmitter, and also the polyphase components of the filters at the receiver. So this is the overall transfer function. It's a matrix transfer function between the input and the output. And we can now derive two types of receivers, multi-carrier transceivers. One is where we use zero padding. The zero padding basically says along with the vector to be transmitted, we append certain number of zeros. The number of zeros we append depends on the length of the channel impulse response. Once we have this type of a response, then we are able to represent the input and output signal. You can see the zero padding that is happening and the output, and then based on this, we can write down the input-output relationship. Input-output relationship is given in terms of a matrix, that is a rectangular matrix, and this can be solved by means of the Moore-Penrose pseudo-inverse. So this was what was shown as the method of designing and building a multi-carrier transceiver where we do zero padding to prevent inter-block interference. And basically, it's a very efficient system. This is something that we can, which can be used. Now, there's a second approach that is used for multi-carrier systems that is based on the use of a cyclic prefix. Now, cyclic prefix says that some portion of the vector to be transmitted is duplicated at the beginning. So, in essence, instead of padding zeros, we are inserting some of the symbols from the transmit sequence itself. So, the generation of the cyclic prefix and the post-processing, if we combine it together, what we get is a overall response that will be related relate the input and the output in terms of a circular matrix. I think this was one of the key concepts that was developed in our lectures. And then finally, using the properties of circular matrices, we showed how if you do the IDFT at the transmitter and DFT operation at the receiver, then we get a very elegant system which can be used in a multi-carrier context and can also build very efficient receivers. So that is the concept of OFDM. So in a nutshell, what we have developed in the context of OFDM would be the following. So it's a multi-carrier system. Multi-carrier system there are two ways that we have built the system. One is through the use of zero padding. The other one is through the use of the cyclic prefix, and both of which are important for us. However, the latter one probably more important because this is the one that leads to the OFDM, what is used in the 4G and possibly the 5G systems as well. So let us now move on to the other elements. The portion that was done prior to the multi-carrier was the aspect of capacity of wireless channels. Capacity of wireless channels. Capacity of wireless channels, a very important concept which actually leads us to the understanding and the derivation of the OFDM system. But let me just highlight what are some of the key elements that we want to carry away from it. So there is a notion of the capacity of an AWG channel, which is logarithm base 2 1 plus the SNR times the bandwidth. This is the fundamental equation. We are always trying to work with this and develop that. Now, when we have a channel where the SNR is not constant, then the SNR, the capacity becomes a function of the SNR, which will then become logarithm base 2 of 1 plus gamma. And this is what led us to discussing the notions of an ergodic capacity. Ergodic capacity. Now, there are two types of environments that in which we look at the capacity of a channel. The first one is a system where you have no information about the channel. No information about channel. This means that only the receiver knows what the channel is. The transmitter does not about channel at the transmitter. Okay, this is the scenario that we call as channel state information at the receiver. And the second one is when we have the information available at the, so full information about channel at transmitter. This is called CSIT. Okay, we looked at both the capacity when we have only information at the receiver, and then also the capacity when you have information, complete information at the transceiver, and then develop the complete understanding. One of the key elements that for the case of CSIT, when you have full information at the transmitter, we also recognize that we can do power allocation differentially. You don't have to allocate power to all channels of different SNRs at the same power level. So power allocation based on SNR. And the optimal method for this is what we saw as the water filling algorithm. So channel state information, optimal approach for achieving capacity is based on the water filling. Let me just show you the slides from the lecture, and hopefully this will refresh the memory regarding that. So water filling, the capacity calculation says that I want to maximize the capacity. Notice that this is the capacity expression in the presence of power allocation. Power allocation for when you have a SNR gamma is given by P of gamma. The total power constraint is given on the first equation. So we want to maximize the capacity subject to the constraint that is given by the average power constraint. This is we solved in the lecture through the Lagrangian method, and we come up with a solution which is called the water filling approach. If you have a reference value 1 over gamma naught, and you're looking at the reciprocal of the SNR, as you go to higher SNR values, that is, as you move to the right, higher SNR, 1 over gamma becomes smaller, and the height or the difference between the reference level and the 1 over gamma curve is the amount of power to be allocated. So in other words, this method suggests that for channels with good SNR, let us allocate more power. Channels with poorer SNR allocate less power, and those channels which are below a certain threshold, no power allocation. So this is called the water filling approach. Now, water filling can be done in order to achieve capacity in two perspectives. The first perspective is I have a channel where the SNR is varying. So you can think of it as a channel where the SNR is varying as a function of time. And for each time instant, depending upon the current SNR, a certain power allocation is done so that we achieve the maximum capacity. Of course, when the SNR goes below a certain threshold, we may choose not to have any transmission. So basically, this is called water filling. It is done as a function of time. Water filling as a function of time. Now, the same technique, when viewed for a wideband channel, you can think of it as a scenario where the wideband signal can be broken up into a number of narrowband channels, and we do water filling based on the channel gain seen by each of these narrowband channels. So this would be called water filling as a function of frequency. And of course, if you have a situation where you have to summarize, this would be called water filling as a function of frequency. And of course, if you have a situation where you have to summarize, this would be called water filling as a function of frequency. So to summarize, water filling is the technique that we are using. We can think of water filling over time. We can think of water filling over frequency, and then of course the combination of these two for wideband signals, water filling over time and frequency. So this is the understanding of capacity. And this is also the point at which we started to introduce OFDM or multi-carrier system, because what we would like to do is to transmit a high data rate, which means I need to have a wideband signal. The wideband signal will see different channel gains for different frequency bands, and this is what leads us to the development of OFDM. So right now in the review, we're kind of covering it in the reverse process. We've already talked about OFDM. We then talked about the channel capacity. Now, what happened before we came to this section, multi-carrier transmission, was the aspects of filter banks. Filter banks. We saw two types of filter banks. First, we looked at the two-channel case, and then the M-channel case. M-channel being the one where you have an arbitrary number of channels, M channels. And in each of those cases, we looked at specific aspects. We eliminating the magnitude distortion. Eliminating, of course, in all cases, we want to eliminate aliasing. Then eliminating magnitude distortion and phase distortion. Eliminating, these are the three things that we want. And if we achieve in eliminating all of them perfectly, then we get the perfect reconstruction system, what we call as PR system. We showed by a sequence of developments how we went from cancelling aliasing, then to cancelling either magnitude or phase response, and then finally looking at the case where you have perfect reconstruction. And then you could extend this to the M-channel case as well. Prior to doing the filter banks, we were looking at the basics of multirate DSP. So let me just, what are the key concepts, basics of multirate DSP? The first and foremost one is concept of sampling, and following which we look at integer changes in sampling rate, downsampling, upsampling, insertion of zeros, upsampling, basically the symbols that we associated with this were downsampling by a factor of m, then the upsampling by a factor of L, and also looked at the filtering, associated filtering that was needed for either upsampling or downsampling. So we had anti-aliasing filtering for downsampling to avoid aliasing for downsampling, and we had interpolation filtering for the upsampling case. Okay, so that removes the unwanted images. Then, of course, we could get various scenarios where you could get combinations of the upsampling and downsampling, along with the polyphase decomposition. So at this point, we should focus on the polyphase decomposition. So these filters can be linked to or implemented via polyphase decomposition. Okay, and then the most efficient architectures are obtained via the noble identities. So the combination, so the foundation of multi-rate signal processing is on the basis of sampling, the integer sampling rate conversion, up and down sampling, what are the associated filterings that go along with it, the most efficient implementation by means of polyphase decomposition, and of course polyphase decomposition has got a type 1 polyphase decomposition and type 2, both we can use both of these, and then we have the noble identities, and then you can have various structures which involve the use of filters, sampling rate conversion, and the implementation of noble identities. So this was the foundational aspect. So to look at the course in the natural flow, we started out with the fundamentals, all of the basic building blocks. This led us to the foremost application of multi-rate signal processing, which is in filter banks. And we saw that we could develop filter banks which would lead us to perfect reconstruction. Using this as a framework, we went on to understanding the transmultiplexer as one of the applications of filter banks, and that is the framework on which we developed multi-carrier transmissions, and this was the one that eventually led us to the OFDM implementation. And then last but not the least, we saw an application of multi-rate signal processing where we used all of our tools, upsampling, downsampling elements to achieve the best possible performance in the context of A to D converters. Okay, so A to D is the one that we want to, that was the last unit that we have covered. Okay, so that sort of hopefully gives you a panoramic view of what the course was all about, and we have had weekly assignments covering that. And I see that now let me just take a quick look at the questions that have been posed. Numerical solutions to numerical problems, assignment 3, question 2. Yes, we've noted that down. Also question 3, numerical problems of assignment 10. Yes, we can take a look at it. Formulas for assignment 8. Yeah, definitely we can post that on the discussion forum. And last question, as per your lecture, the answer of assignment 9 question 2 comes to option C, but the answer is B is correct. Okay, we will also ensure that the clarification that has been asked for assignment 9 question 2, we will make sure. Occasionally there may have been misnumbering, but we will make sure that a clear answer is given as far as the what would be the best, what will be the correct answer and why that is the correct answer. Please feel free tomorrow, day after also, whenever you need to have doubts clarified, please post it on the discussion group. We will be monitoring it constantly, because I know that as you prepare for the examination, there may be doubts that come. If there are any doubts on the lectures, lecture notes, anything that is not very clear, please post it on the forum. We will answer it as soon as possible. So that is the commitment from our side. Any other points that you would like me to clarify as we give as part of this live interaction? Anything else? So in case you missed the starting point of the discussion, the examination will consist of 50 multiple choice questions, similar in nature to what you have seen in the assignments, but probably a little bit higher in terms of the level of difficulty. No descriptive questions, all of them are problem based. They will be testing the concepts that you have studied and applying the concepts in the context of the items that we have covered. So the best preparation, I would say, is to review the lectures, write down the key formulae, so that that will help you review all of the key elements, particularly when you look at the expressions for upsampling, downsampling, the filter banks, properties such as power complementarity, all pass functions. So basically, there are several concepts that we have covered as part of the course. I would say that it would be very helpful if you write down the formulae so that you can review them and use them as a reference to refresh your memory. So once you have gone through the lectures and prepared the formula sheet, then I would definitely recommend you to review the multiple choice questions and particularly focus on any question that you may not have chosen the correct answer. If there is still a doubt that is in your mind, just post it. We will answer it with a detailed explanation so that it will help you and also help others who are also preparing for the exam. So that is from what we can do from our side. We are ready to help in whatever way we can. I would like to thank you very much for being a part of the course, and I hope you have enjoyed it, and do take the time to give the feedback when the NPTEL coordinators will be asking you for the feedback on the course. Okay, I think we have already answered regarding the questions for solutions for the assignments. Please let us know specific questions for which you want answers. We will be able to provide. Generally, as a guideline, NPTEL does not produce the complete solutions because these are questions that we want the student to at least attempt before seeing the answers. Because the way the practice that we follow at IIT is that once a student has seen the solution, it may seem very easy, or it may seem very obvious, but definitely not obvious if you have not solved this problem yourself. So we always, as a pedagogical method, we always want the student to try first and then look at the solution, not the other way around. So again, if you have faced any difficulty on any particular question, please post it. I think we have noted down the questions that have been suggested or proposed by Maumita. We'll definitely make sure those questions are answered. So Meenakshi, Meghna, please do let us know specific assignments and questions on which you are having a doubt or you would like to have additional information. Okay. Any other points that that I can discuss that could be of help in terms of preparation for the exam? If not, let me say thank you to joining for this live session. We will be monitoring the discussion forum. If there are any doubts, please post them on that. We will make sure that they are answered as quickly as possible so that you can continue on in your preparations for the examination. So I wish you all the best, not only for the examination, but also beyond that. And I hope you will have a chance to use the concepts that we have studied in the course. And please do keep in touch, and any feedback I would be happy to receive from you. My email ID, as you would have seen on the course website, it is davidk@iitm.ac.in. Please do feel free to drop me an email if you would like to give any points of feedback. But as far as the clarifications and doubts and doubt clearing, we can do that either by personal email or by the discussion forum. We will make sure that all the answers are posted on the forum so that it would be of benefit even to other students, so that they can also see what questions have been asked and what were the answers. Okay, so with that, let me sign off. Thank you very much. This is Professor David signing off from IIT Madras.